The ocean predator that humans were never supposed to see represents more than just an undiscovered species. It embodies an evolutionary success story, hidden beneath kilometers of water and darkness. Its existence suggests that the deepest regions of the ocean support complex ecosystems far more intricate than previously imagined. These environments, shaped by crushing pressure and perpetual night, may harbor apex predators that have thrived independently of surface conditions and human influence for millions of years. In this context, the predator emerges not as an anomaly, but as an inevitable product of deep ocean evolution. Life in the abyss is defined by scarcity, requiring organisms to adopt strategies that maximize efficiency and survival. The predator's stealth, sensory precision, and metabolic resilience reflect adaptations honed over vast geological timescales. It evolved in isolation, guided by pressures unique to the deep, infrequent prey opportunities, narrow thermal gradients, and the need to navigate an environment that offers no visual cues. The creature's presence has implications for the structure of deep-sea food webs. As an unseen apex predator, it may regulate populations of mid-level predators, maintaining ecological balance within areas inaccessible to sunlight-based productivity. This regulatory role could be essential for the stability of trench ecosystems, where a single disruption can cascade across layers of interdependent species. Its avoidance of shallow waters suggests an instinctual separation between its environment and the surface world. The upper ocean, filled with light, sound, and unfamiliar biological profiles, may represent a foreign realm outside the predator's evolutionary domain. Its adaptations reinforce this boundary. Acoustic camouflage that functions best in deep pressure zones, sensory organs tuned to the faint vibrations of abyssal life, and metabolic processes optimized for cold, dense water. As human exploration penetrates deeper into the ocean, the predator's world becomes increasingly vulnerable. Deep-sea mining, seismic exploration, and submersible activity introduce noise and disturbances that may affect the creature's behavior. Disruptions to migratory prey, sediment plumes, and changes in water chemistry could alter its hunting grounds. Yet the predator's resilience suggests that it may adapt, shifting its territory deeper into trenches or relocating to regions far from human activity. The ethical considerations surrounding the predator's discovery are profound. Revealing its existence to the scientific world carries the risk of exploitation, disturbance, or environmental harm. Deep-sea species have historically suffered under human curiosity, often losing their habitats before researchers fully understand their roles. To protect this creature, some propose that its existence should remain speculative, preserved through indirect evidence rather than intrusive exploration. Nevertheless, the predator's significance extends beyond ecological impact. It expands the boundaries of what life can be, challenging assumptions about biological limits. Its mastery of stealth and sensory precision demonstrates evolutionary pathways not seen in surface species. It occupies a world shaped by pressure and silence, suggesting that intelligence and adaptation can evolve in forms unfamiliar to terrestrial paradigms. The ocean predator reminds humanity that Earth remains largely unexplored. Despite advances in technology, the deepest trenches and basins continue to resist comprehensive study. These untouched environments harbor life forms that operate on ancient rules, impervious to surface concerns. The predator is one of these beings, a symbol of the ocean's hidden power and a testament to nature's ability to craft organisms perfectly suited to their environment. In the end, the ocean predator continues to glide unseen through its dark domain, indifferent to the world above. Its presence lingers in the data collected by machines and the anomalies recorded by instruments, hinting at a reality that remains just beyond the limits of human perception. Humans were never meant to see this creature, and perhaps that distance is what allows it to thrive. It endures in silence, the unseen apex of the abyss, moving through a realm where light has no meaning and evolution has forged a predator unrivaled across the hidden depths of the earth. Far beneath the boundary where surface radiance dissolves into the abyss lies a world hidden from ordinary observation. The ocean's midnight zone stretches across the planet like an endless frontier, absorbing sunlight, sound, and certainty. Here, pressure rises to levels that would crush steel, and temperatures drop until water becomes a cold, dense mass. The environment supports organisms adapted to perpetual darkness, each carrying traits forged through millions of years of evolutionary pressure. Yet within this realm of predators and prey, there exists one entity that stands apart from the catalog of known life, a creature so elusive, so perfectly adapted to concealment, that it has remained undocumented throughout nearly all of human history. For centuries, myths have captured fragments of this entity's existence. Sailors spoke of shadows that moved against deep currents, of mass displacements in the water that could not be attributed to whales or giant cephalopods. These accounts were dismissed as superstition, illusions born from exhaustion and isolation. Nevertheless, the stories persisted, echoing across generations in coastal cultures separated by continents yet united by similar descriptions. The predator existed in their narratives as something that did not surface, did not breach, and did not reveal itself except through momentary disturbances in the ocean's stillness. Modern exploration tools, sonar arrays, hydroacoustic sensors, deep-sea drones have expanded humanity's reach into previously uncharted depths. Despite this, the predator has managed to avoid detection. Its habitat lies below the threshold where most technologies function reliably, in a zone where cold, mineral-rich water circulates through trenches and canyons. These regions remain unstable, filled with thermal vents, shifting sediment clouds, and environmental noise that obscures movement. The predator thrives here, using the darkness as a shield and the pressure as a barrier against intrusion. What distinguishes this creature from other deep-sea inhabitants is not merely its size or behavior, but the ecological niche it occupies. Evidence suggests that it inhabits a layer of water known as the acoustic shadow zone, an area where sound waves bend due to temperature and pressure gradients, allowing the predator to move without producing detectable echoes. This adaptation grants it near-perfect stealth. It glides through the darkness in complete silence, sensing vibrations with an efficiency unmatched by known species. The predator's existence is inferred from anomalies recorded during oceanographic surveys. Seafloor seismographs sometimes detect rhythmic pulses unrelated to tectonic activity, while drifting buoys report transient pressure waves inconsistent with submarine or whale movements. In rare cases, remotely operated vehicles have captured fleeting distortions in the water, as if something massive passed just beyond camera range. These events are often followed by abrupt malfunctions and signal loss, suggesting interference from an unknown biological presence. Despite these clues, the predator remains almost entirely beyond human reach. Its environment is too deep, too treacherous, and too vast for direct observation. The creature's elusive nature raises the possibility that its avoidance of detection is not accidental but the result of evolved behavior. Through countless generations, it may have developed instincts that compel it to maintain distance from surface disturbances, avoiding light, noise, and mechanical activity associated with human technology. The ocean hides many mysteries, but few evoke as much intrigue as the predator that moves through its depths unseen. It belongs to a world shaped by pressures incompatible with human life, a world where survival demands abilities honed through millennia of isolation. This predator, designed by nature to remain hidden, drifts in the abyss, a creature humans were never meant to witness. Although the predator has never been observed directly, cumulative data from acoustic readings, pressure signatures, and rare biological traces allow a partial reconstruction of its anatomical structure. What emerges is a creature with traits that defy traditional categories in marine biology, blending features from multiple evolutionary lineages while introducing entirely unfamiliar characteristics. Hydrodynamic modeling indicates that the predator possesses an elongated, flexible form optimized for efficient movement through deep water currents. Its body likely consists of layered musculature intertwined with structural fibers capable of resisting extreme compression. These fibers may function similarly to the flexible collagen matrices found in deep-sea gelatinous organisms, yet they possess the durability of cartilaginous frameworks. This combination enables the predator to navigate with both power and subtlety, maintaining stealth while moving at speeds sufficient to capture fast-swimming prey. The predator's surface tissue exhibits properties that render it nearly invisible to sonar. Instead of reflecting sound waves, it appears to absorb and scatter them across its body, producing signatures indistinguishable from ambient water. This bioacoustic camouflage likely relies on a multi-layered skin composed of microscopic structures that manipulate sound in ways similar to optical cloaking seen in certain cephalopods. Through this adaptation, the predator effectively dissolves into its environment, erasing the auditory footprint that would otherwise expose its presence. Thermal imaging from autonomous deep-sea probes has revealed intermittent patterns of localized heat dissipation. These thermal anomalies suggest a metabolically active organism capable of generating internal warmth despite the surrounding cold. The heat distribution pattern is uneven, clustered around what appear to be sensory organs aligned along its lateral surfaces. These sensory structures may detect thermal gradients, minute vibrations, and low-frequency pressure waves. Their sensitivity surpasses existing marine analogs, granting the predator a sensory map of its environment extending far beyond its immediate vicinity. Chemical analysis of water samples taken from regions associated with the predator reveals traces of complex protein structures unlike those found in known marine species. These proteins remain stable under high pressure and low temperature, indicating highly specialized biochemical processes. Some compounds exhibit photoreactive properties, suggesting that the predator may possess internal bioluminescent organs. However, unlike typical deep-sea organisms that use light for luring prey or communication, the predator likely employs bioluminescence in wavelengths beyond human detection, illuminating its surroundings in a spectrum perceptible only to itself. Feeding mechanisms inferred from environmental disturbances point to a method of predation based on sudden bursts of acceleration. The predator remains motionless for extended periods, blending into the thermal and acoustic environment. When prey draws near, it launches forward with explosive force, creating a transient cavity in the water. This phenomenon, detected by high-frequency hydrophones, indicates a feeding strategy comparable to ambush predators. The creature's jaw structure, if jaws are present at all, may involve multiple layers of flexible tissue capable of enveloping prey rather than tearing it, reducing sound and minimizing the risk of detection by other large creatures. The predator's reproductive biology remains entirely speculative. Its absence from shallower waters suggests that reproduction occurs at great depths, potentially near hydrothermal vents where warmth and chemical gradients create stable nurseries. Genetic material retrieved from deep-water sediment may contain fragments associated with the organism, indicating slow developmental cycles and long lifespans spanning centuries. The ocean predator's anatomy reflects an organism sculpted by evolutionary forces unique to the abyss. Every adaptation reinforces its invisibility, survival efficiency, and dominance within an environment hostile to most forms of life. Through this intricate design, it maintains a presence unseen, unheard, and almost unknown, a living shadow moving through the deep. The existence of the unseen predator is supported not by direct encounters, but by the cumulative weight of anomalies recorded across decades of oceanographic research. Each anomaly, when isolated, appears insignificant: an unexplained sensor malfunction, a disrupted data stream, a deviation in migration patterns of deep-sea fauna. Yet examined collectively, these irregularities form a compelling narrative. Something large, living, and highly intelligent moves through the ocean's darkest regions. One of the earliest indicators came from hydrophone networks deployed to monitor seismic activity and submarine traffic. These arrays detected intermittent low-frequency signatures that did not correspond to known marine animals. The pulses were too structured to be geological noise and too faint to originate from whales. They traveled in patterns suggesting deliberate movement, often intersecting with regions populated by dense clusters of deep-water prey species. Later, autonomous submersibles reported unexpected power drains and navigational errors while operating in certain trenches. Their sensors registered momentary electromagnetic interference, implying the presence of a biological organism capable of generating weak electromagnetic fields. Whether this capability serves communication, navigation, or predation remains unknown, but its detection reinforces the predator's capacity to influence its surroundings without revealing itself. Marine ecosystems exhibit further evidence of the creature's existence. In areas associated with its presence, researchers observed unusual fluctuations in fish populations. Prey species disappeared abruptly from specific regions, only to reappear months later. These shifts did not align with seasonal migration or environmental stress. Instead, they mirrored the movement patterns inferred from acoustic anomalies, suggesting a predator whose hunting ranges span vast distances. Deep-sea sediment samples reveal circular depressions and gouges inconsistent with geological processes. These markings likely result from sudden bursts of force applied by a large organism moving rapidly near the seafloor. Further supporting this interpretation are water column disturbances observed on sonar scans, vertical plumes of displaced sediment rising from depths where known predators rarely operate. The predator's presence also affects larger marine animals. Tagging data from deep-diving species, such as elephant seals and sperm whales, show abrupt course changes, rapid ascents, and extended pauses at mid-depth. These behaviors typically occur when animals detect threats. In several cases, archival tags recorded sharp vibrations and sudden drops in ambient noise, implying close encounters with something massive moving silently through the water. On rare occasions, deep-sea cameras have captured fleeting shadows or blurred silhouettes passing beyond their field of view. These instances always occur at the limits of available lighting, as if the creature instinctively avoids exposure. The shape appears elongated, flexible, and extraordinarily large, far surpassing typical cephalopods or predatory fish. Although these visual traces lack clarity, they match the dimensions extrapolated from acoustic and pressure data. The predator's impact extends even to ocean currents. Numerical models sometimes fail to account for deviations in local water flow, only to align perfectly when researchers incorporate the hypothetical displacement caused by a large organism moving through the area. This suggests that the predator's mass is substantial enough to alter microcurrents, yet its movement remains too smooth to create detectable turbulence. Perhaps the most compelling evidence comes from the absence of typical predator-prey interactions in regions associated with the organism. Deep-sea ecosystems rely on delicate balances, yet in these areas, apex predators avoid hunting, as if responding to an unspoken hierarchy. This behavioral shift implies that the unseen predator occupies the top of the food chain, exerting dominance through sheer presence. Together, these signs form the outline of a creature humanity was never meant to witness: an apex hunter perfectly attuned to a world of darkness, silence, and pressure. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.